Okay, so you're probably feeling it too, right? This absolute flood of AI news, AI tools, AI everything. It's everywhere. And trying to navigate it all, I mean, how do you cut through the noise? How do you really get a handle on the incredible power, but also, let's be honest, the kind of tricky pitfalls? It's easy to feel overwhelmed or like you're drowning in jargon. We want you to feel genuinely well informed, not just bombarded. So that's exactly what we're doing today. We're taking a deep dive into something that's becoming, well, really foundational for navigating this new territory. It's the National Institute of Standards and Technology's AI 101. Specifically, the Artificial Intelligence Risk Management Framework, or AI RMF 1.0. Now, don't tune out just because it sounds like a government doc. Think of it more like a crucial guide. It's voluntary, flexible, not tied to one industry. Basically, a playbook for organizations to harness the good stuff in AI and, really importantly, protect against the potential harms.
That's absolutely right. And what's really key here, I think, is that this framework, it's not just for the tech gurus, the data scientists locked away somewhere. No, it's explicitly designed for anyone involved with AI systems, from the initial idea, the design, all the way through development, deployment, and even for the folks who end up using it. And they call it a living document, which is important. It's meant to change and evolve as the tech does, and as we learn more about how these systems actually work out in the real world.
Okay, let's unpack that a bit. We hear AI system thrown around constantly, but what does NIST actually mean by that in this framework? And maybe more importantly, what makes managing the risks associated with AI so different, so uniquely challenging compared to, say, regular old software problems? Because you'd think we'd have risk management down by now, wouldn't you?
You really would think so.
Yeah.
Uh, NIST defines an AI system pretty clearly. It's an engineered or machine-based system that can, for a given set of objectives, generate outputs such as predictions, recommendations, or decisions influencing real or virtual environments.
Hmm.
So basically, systems that learn and make decisions, often with different levels of autonomy. But where this framework really breaks new ground is in spelling out why AI risks are fundamentally different from traditional software risks. We've spent decades building standards for regular software, right?
Mm.
But AI throws in these complexities that, well, the old way just can't fully handle.
So it's not just a fancier type of code then. What are some of those key differences? What makes AI risk management its own kind of beast?
Well, there are quite a few, and they really get to the heart of what makes AI unique. One of the biggest, data issues. Think about it.
Mm.
An AI is only as good as its training data, but that data, it might not truly represent the real world it's supposed to work in, or maybe the ground truth it's learning from isn't even perfect to begin with. And data gets stale, it can drift over time, meaning it doesn't match reality anymore. And that's where things like harmful bias or just plain quality problems can sneak in and they get massively amplified by the AI.
Right, the garbage in, garbage out problem, but on a massive scale.
Exactly, but potentially much more subtle and harder to spot.
Hmm.
Then you've got the sheer scale and complexity. We're not talking about code you can easily trace line by line. Some AI systems have billions, maybe even trillions of internal decision points. Trying to grasp exactly how that works, it's incredibly challenging to manage comprehensively.
Like trying to map a brain.
Sort of, yeah. And then there's the use of pre-trained models, these huge ready-made AI components that developers adapt. They speed things up, sure, but they also bring their own baggage. Built-in statistical uncertainty, making bias management really complex, issues with reproducibility. It makes predicting how these massive things might fail very, very difficult.
Okay, so hidden uncertainties baked right in.
Pretty much. And we're seeing new privacy risks, too. AI is just so good at pulling together and analyzing huge amounts of data, creating new ways privacy can be breached. Plus, maintenance is different. AI systems often need more frequent updates because of that data drift or model drift we mentioned. Things change. The AI's performance can degrade if it's not kept current.
So it's not just set it and forget it.
Definitely not. There's also the opacity problem, the black box.
Oh.
It's often really hard to understand why an AI made a specific decision or even to get the same result twice reliably. And on top of that, the testing standards for AI, they're still catching up. It's just harder to rigorously test these systems compared to traditional software, less predictable.
That makes sense.
And finally, yeah, those traditional risk frameworks we rely on, they just weren't built for this. They struggle with things like generative AI, the tech behind chatbots and image tools you see everywhere now. They also have trouble with specific AI attacks, like trying to trick the AI with subtly changed inputs, that's evasion, or trying to steal the model itself, model extraction. And they don't really cover risks from third-party AI components or when AI is used off-label, for something it wasn't originally designed or tested for.
Wow, okay. That's quite a list. It definitely paints a picture of a unique challenge. So, if the risks are this complex, this different, how does NIST suggest we even think about risk here? And you mentioned things like opacity making it hard. What are the big hurdles NIST points out when it comes to actually, measuring these AI risks?
That's a really central question. The AI RMF defines risk as uh, a composite measure of an event's probability of occurring and the magnitude or degree of the consequences.
Yeah.
So it's a mix. How likely is something to happen, and how big is the impact, positive or negative, or maybe both?
Probability times impact, basically.
Essentially, yes.
Yeah.
But you're right, measuring it is tough. The framework is upfront about how hard it is to quantify new emergent risks or deal with those opaque black box systems. And then there's risk tolerance. This is key. The framework doesn't tell you what level of risk is okay. It says risk tolerance is highly contextual and application and use case specific. It depends heavily on laws, regulations, company policies, societal norms.
So, what's acceptable for a movie recommender is totally different from, say, a medical diagnostic AI.
Exactly. Totally different stakes. Organizations have to figure out what's acceptable for their specific situation, and that line might move over time as we learn more. Now, connecting this back, the whole point of managing these risks isn't just avoiding bad outcomes. It's about building what NIST calls trustworthy AI systems. These are systems that actually meet the needs and values of everyone involved. Enhancing trustworthiness is how you directly reduce those negative risks. It's proactive.
Trustworthy AI. Okay, that sounds like the goal. So, what does that actually mean according to NIST? What are the core characteristics we should be looking for in an AI system to call it trustworthy?
NIST lays out 7 key characteristics, and it's helpful to think of valid and reliable as the base, the foundation, and then accountable and transparent are sort of cross-cutting. They weave through all the others.
Got it. Foundational and cross-cutting. So, what's first?
First is valid and reliable, pretty straightforward. Is the AI accurate? Does it do what it's supposed to do reliably without failing under normal conditions? And is it robust? Can it handle unexpected inputs or situations? This demands ongoing testing and monitoring.
Makes sense. Accuracy and reliability. What's next?
Safe. An AI system shouldn't endanger people, property, or the environment under defined conditions. This means thinking about safety right from the design phase, using simulations, having real-time monitoring, and critically, having ways for humans to step in or shut it down if needed.
The emergency brake, basically.
Exactly. Then, secure and resilient. Can the system withstand attacks or unexpected events? Can it keep working, or at least fail gracefully without causing chaos? This covers cybersecurity stuff, like defending against those adversarial attacks or the data poisoning attempts we talked about.
Okay, secure from tampering.
Right. Now, 2 really important ones that are closely linked: accountable and transparent. Transparency means you can get information about the system, how it was designed, what data it trained on, its intended use, how it makes decisions. This is often essential if something goes wrong and you need to figure out why or seek redress. Accountability relies on this transparency, making sure someone is ultimately responsible for the AI's actions. A black box makes both really difficult.
So you need to be able to see inside, at least to some extent.
You do. And related to that is explainable and interpretable. Explainability is about understanding how the system works, the mechanics. Interpretability is about understanding the meaning of its output, why it made a particular recommendation or decision. These help everyone, operators, regulators, users, understand if the system is working as intended. Think of it like transparency tells you what happened, explainability tells you how, and interpretability tells you why.
That's a useful distinction. What else?
Privacy enhanced. This is about protecting people's autonomy and dignity, giving them control over their information, limiting unwanted observation. Technologies like putties, privacy-enhancing technologies, and just minimizing the data collected are key here.
Protecting personal data. Got it.
And finally, number 7, fair with harmful bias managed. This is huge. It's about equity and equality and recognizing that bias isn't just about obvious demographic stuff. NIST talks about bias coming from the systems, from the data, even from our own human cognitive biases when we interact with AI. Not all bias is bad, but AI can amplify harmful biases incredibly quickly and widely.
That bias point seems critical.
It really is. And one last crucial point about all 7 characteristics. There are often trade-offs. Making a system more interpretable might make it slightly less private, for example, or maxing out accuracy might make it harder to explain.
So you can't always have everything perfectly balanced.
Exactly. Balancing these trade-offs is a shared responsibility for everyone involved in the AI's lifecycle. and it has to be decided based on the specific context of that AI system.
Okay, that gives us a really solid picture of what trustworthy looks like. But like you said, the framework isn't just definitions, it's meant to be actionable, right? You mentioned a core with 4 functions.
Yes, exactly. This is where the rubber meets the road. The core is built around 4 functions: govern, map, measure, and manage. They're high-level functions, each broken down into more specific categories and subcategories. But critically, it's not a checklist you just work through once. It's meant to be a continuous, iterative process. And govern is really foundational. It underpins and influences everything else.
Okay, continuous and iterative. Let's start with govern then. What's its main job?
Govern is all about creating and maintaining a culture of AI risk management within an organization. It's about putting the right policies, processes, and accountability structures in place. Think about leadership commitment, making sure decision-making involves diverse teams, promoting that culture of critical thinking and safety. It's setting the stage, the organizational foundation for everything else.
So, getting the house in order first makes sense. Once that governance structure is there, what's the next step in the cycle?
From governance, you typically move into MAP. This function is about establishing the context for a specific AI system. What's its intended purpose? What are the potential impacts, good and bad, on people, on society? What are the legal requirements or norms we need to consider? MAP is where you gather all that background knowledge, understand the landscape for this particular AI. It's really designed to inform that crucial early decision. Should we even build or deploy this system, given what we now know about its potential effects? That gotta-go point.
Right, understanding the terrain before you march forward.
Right.
Okay, after map becomes measure. How does that work in practice?
Measures where you actually start employing tools and methods could be quantitative, qualitative, or a mix to analyze, assess, benchmark, and monitor the AI risks and impacts you identified in a mapper. This means rigorous testing, checking performance against metrics for all those trustworthy characteristics: safety, security, fairness, privacy, explainability, the whole list. It also involves tracking how the system performs over time, looking for emergent risks, and importantly, incorporating feedback from users and affected communities into how you evaluate the system.
So actually testing and tracking against those trustworthiness goals. And finally, manage.
Manage takes everything you've learned from map and measure and focuses on allocating resources to deal with the identified risks. This means prioritizing risks, deciding how to respond. Maybe you mitigate the risk, maybe you transfer it, maybe you avoid it altogether, or maybe you consciously accept it. It's also about documenting any risks that remain and having clear plans for responding to incidents or failures. This includes having ways to override, disengage, or even shut down an AI system if it's not performing properly or causing harm.
Planning the response and having kill switches, essentially. It sounds incredibly thorough, a very holistic cycle, which brings up the question, who exactly needs to be involved in all this? It can't just be the tech team, surely.
Oh, absolutely not. The framework is very clear on this. Managing AI risk needs a wide range of perspectives and skills involving different actors across the entire AI lifecycle. It's framed as a collective responsibility. And they specifically highlight how having diverse teams, diverse in experience, background, expertise, is crucial for actually spotting potential problems that a more homogeneous team might miss.
Okay, so not just developers. Who else are we talking about? Give us some examples of these key players and the roles they play.
Yeah, it's quite a broad group, laid out nicely in an appendix, actually. You've got AI design actors. These are the people creating the concepts, the objectives. They handle planning, data collection, making sure it's fit for purpose. This includes data scientists, yes, but also domain experts, people who know the area the AI will work in, sociocultural analysts, human factor specialists, DEIA experts, even members of communities likely to be impacted.
So bringing in social science and lived experience right at the start.
Exactly. Then you have AI deployment actors. They're making the decisions about how the system is actually used in the real world. Think system integrators, the end users, the operators on the ground.
The people using it day to day.
Right. And then, very important, TEVV actors. That stands for test, evaluation, verification, and validation. These folks examine the system throughout its life cycle to find and fix problems. Ideally, NIST suggests these people should be separate from the team that built the system to provide that independent oversight.
An independent check, that makes sense.
Then there are governance and oversight actors. This is management, senior leadership, maybe even the board of directors. They're responsible for the organization's overall approach to AI and its impacts.
That's strategic level.
Precisely. And lastly, but maybe most importantly in some ways, they list the general public. Why? Because the public is most likely to directly experience positive and negative impacts.
Hmm.
Their experiences really provide the motivation for all the actions the other actors take. It grounds the whole framework in real-world consequences.
That's a really comprehensive view of who's involved. Okay, so with all these functions and all these actors, how does an organization actually use this framework? Is it one size fits all, or can you tailor it?
Oh, it's definitely designed to be tailored. The framework introduces the idea of AI RMF profiles. These are basically customized versions of the framework for specific needs. So you could create a use case profile, like an AI RMF hiring profile, that really focuses on the fairness and bias aspects for recruitment AI, or a fair housing profile for AI used in lending or property assessments.
Tailored to the specific application.
Exactly. There are also temporal profiles. An organization might create a current profile. Here's how we manage AI risk now, and compare it to a target profile. Here's where we want to be. That comparison highlights the gaps and helps them build a roadmap for improvement. It's a strategic planning tool.
Like a gap analysis for AI risk.
Pretty much, yeah. And they also mention cross-sectoral profiles for AI models or services used across different industries, like those big foundation models or cloud AI platforms. The key thing is that the framework isn't prescriptive. It doesn't tell you exactly how to do everything. It offers the structure, the functions, the considerations, but allows flexibility for organizations to adapt it based on their size, their resources, their specific context.
So, what we've really unpacked today, it seems, is that managing AI isn't just a technical puzzle for engineers to solve. It's fundamentally socio-technical. It involves this complex dance between people, processes, technology, and a real commitment to constantly learning and improving. It's about building and deploying AI with a deep sense of responsibility, really understanding its potential ripples through society.
That's a great way to put it. This framework, I think, is so valuable because it forces that critical thinking. It pushes organizations, and hopefully individuals too, to question assumptions, to look at the whole picture of AI's effects. It serves as a reminder that building public trust in AI isn't just about good PR or marketing slogans. It has to be earned through rigorous risk management, through transparency, and through a genuine commitment to putting human well-being at the center.
So here's something to think about as we wrap up. The next time you interact with an AI, and let's face it, that's happening more and more, whether you actively realize it or not, maybe it's your streaming service, a customer service bot, maybe something more complex. Consider this kind of invisible framework operating, or hopefully operating, behind the scenes. What responsibility do you think we as individuals have in understanding this stuff and maybe even advocating for the trustworthy, responsible development of the AI systems that are increasingly shaping our lives and our world?